For any electronic components to function, it needs to be powered. Let us go ahead and learn what is a voltage and how it relates to electronic components. Voltage is basically a potential difference between 2 points. It makes electrons move, generating a current. With current, the electronic components are able to function. You can see that this is 6 volts. This point is 6 volts and this point is 3 volts. Now, what if we connect 6 volts the positive terminal, and then connect the 3 volts on the negative terminal. So then the component will be powered by 6 minus 3, which is the total of 3 volts. The potential difference between 2 points is 3 volts. And so if we start the simulation, the component will be powered by 3 volts. To show you a much simpler example, let us start with a battery. This battery have a negative terminal and a positive terminal, and it is rated to have 3 volts. This means that the potential difference between the negative terminal and the positive terminal is 3 volts. Now, normally when it comes to battery, the negative terminal is 0 volts. The negative terminal is 0 volts, or what we call a ground. And then the positive terminal will have the rated volts, in this case 3 volts. And so this battery will be able to power a component 3 volts minus 0 volts, which is a total of 3 volts. So if we can to power a component, it will always require a certain voltage. So for example, for LED lights, the cathode will connect to the negative terminal, and then the anode will have to be connected to the positive terminal. Normally the cathode is the longer part, and then the anode is the shorter part of an LED light. So let's run the simulation, and as you can see, the electric component, the LED light, is being powered. And other electrical components have the label power and ground, or in this case 5 volts and ground. So it works the same way. We connect the ground to the negative terminal, and then we connect the 5 volts or the power to the positive terminal. And now the electric components can now function. To relate all of this to Arduino, the negative is the ground, and then the positive are the pins that give output voltages. So it can be the 3.3 volts, the 5 volts, or even the digital pins, since the digital pins can output up to 5 volts. So for example, if we were using a certain sensor, like the ultrasonic, in order for this to function, it needs to be powered by 5 volts. And so we connect it to ground and to 5 volts. And now this component can function. The third pin is for sending information. In this case, we are sending information to the Arduino board. Don't worry, as we will tackle more about sensors in later videos. Another example, what if we want to power a light source and we want to control it when it turns on and when it turns off. So in this case, we use the digital pins since the digital pins provide 5 volts output. So let's have an LED light. Let's make it into green. And let's connect the cathode to ground. And let's connect an anode to any digital pin. And we let the code do the work to schedule when it will turn off and when it will turn on. Then it is up to the code to control when the light will turn on and off. Don't worry, the coding process will be taught in the next videos. So if we start the simulation, it should turn on for 1 second and then turn off for 1 second, and the cycle repeats. So basically, in an Arduino, when we are connecting electronics component, we are always connecting something to ground and something to power. In the case of sensors, we are powering the sensors in order for them to function. So we connect it to ground and to power, and then the third pins or the additional pins the sensors have usually will be connected to analog pins or to digital pins to send information. This video was about how to power electrical components using the Arduino. In the next video, we will be talking about the breadboard and how it functions or how to use it in building electrical circuits.